It's very important to note that in probability, OR means add. And in a normal deck of cards, there are 52 cards. Okay, so there's a few ways we can answer this question. The first way is using a Venn diagram. So we're going to let the cardinal number of elements of the universal set be the number of cards in a normal deck. We're going to let the cardinal number of elements in K be the number of kings in a normal deck of cards. And we're going to let the cardinal number of elements of Q be the number of queens in a normal deck of cards. So we start by drawing out a rectangle with a capital U that represents the universal set. We have a circle with a K, which represents the king set. We have a circle with a Q that represents the queen set. So we know there are 4 kings in a pack, and we know there are 4 queens in a pack, and 52 minus 4 minus 4 leaves us with 44. So from the Venn diagram, the set K has 4 elements, and the set Q has 4 elements, and the number of king or queens is going to be the cardinal number of elements in K union Q, which is going to be 8. So 4 plus 4 is 8. Remember, OR means add. OR in probability means add. So the probability of getting a king or a queen when selecting a playing card is 8 over 52, because 52 is the total. Remember, probability is what we want divided by the total. So we want the probability of a king or a queen, and there are 8 cards in total that are kings or queens, and that's divided by the total, which is 52, and 8 over 52 simplifies to 2 over 13. Another way we can work out this question is using a sample space diagram. We can list all the cards in a normal deck. We remember that we're looking for a king or a queen, which in set theory means we're selecting either a king or a queen, so we highlight both types of cards. So here we have the hearts, the diamonds, the clubs, the spades, so we highlight the 4 kings and the 4 queens. We have highlighted 8 cards out of a possible 52. So the probability of getting a king or a queen when selecting a playing card is 8 over 52, which is 2 over 13. Another way we can do it is by counting outcomes. Probably the easiest way is to count the number of outcomes that would give us a king or a queen. A king, there are 4 outcomes. A queen, there are 4 outcomes. The total number of desirable outcomes is 8. The total number of possible outcomes is 52. So the probability of getting a king or a queen when selecting a playing card is 8 over 52, which again is 2 over 13. From this example, it is clear that when dealing with OR events, we add. Of course, we may deal with problems that are not mutually exclusive, i.e. they have events in common. What is the probability of getting a king or a club when selecting a single playing card from a normal deck? So remember, OR means add, and there are 52 cards in total in a normal deck. So let's start by using a Venn diagram. Let the cardinal number of elements in U, the universal set, be the number of cards in a normal pack of cards. Let the cardinal number of elements of K be the number of kings in a normal deck of cards. And let the cardinal number of elements in C be the number of clubs in a normal deck of cards. So we draw out our rectangle and label it as a capital U, the universal set. We draw a circle and label it as K. We draw another circle and label it as C. This time the circles have to intersect. We know there are 52 cards in a total deck, and we know there are 4 kings, one of which is a club. So we put 1 in the intersection. There are 3 kings that are not clubs, so they go on the other part of the king set. We know there are 13 clubs in total because each suit has 13 cards. One of them is a king, which is why we have 1 in the intersection. So there are 12 clubs that are not kings, so 12 goes in the other part of the club set. And then 3 plus 1 plus 12 makes 16 cards in total. And 52 take away 16 leaves us with 36. So there are 36 cards left over in the universal set. We must pay particular attention to the intersection, as we have one card that is a king of clubs. We must not count this card twice. This is referred to as double counting. From the Venn diagram, the number of kings or clubs is the cardinal number of elements of K union C, which is 16. So 3 plus 1 plus 12 is 16. So the probability of getting a king or a club when selecting a playing card is 3 plus 1 plus 12, which is 16 over 52, because remember there's 52 cards in total, and that simplifies to 4 over 13. So really important that we must not count the king of clubs twice. We must not double count. So we could also have worked this out using sample space diagrams. We can list all the cards in a normal deck. Remember that we are looking for a king or a club, which in set theory means we are selecting either a king or a club, so we highlight both types of cards. So we have the hearts, the diamonds, the clubs and the spades. We highlight all of the clubs, and we highlight all of the kings. And we count them up and we work out that we've highlighted 16 cards out of a possible 52. So the probability of getting a king or a club when selecting a playing card is 16 over 52, which again is 4 over 13. And we can also work this out by counting outcomes. We can count the number of outcomes that would give us a king or a club. King, there are 4 outcomes. Club, there are 13 outcomes. And king of clubs, there's 1 outcome. We must subtract this from our total so as to not double count. So the total number of desirable outcomes is 16. So 13 clubs plus 4 kings minus 1 king of clubs. The total number of possible outcomes is 52. So the probability of getting a king or a club when selecting a playing card is 16 over 52, which is 4 over 13.